Back again for our third and final example of force vectors. So the example we've got here is somebody, it's Jada actually, sliding down a slide, and her velocity is constant. That's a really important point to note. So her velocity is constant. So state the size of the net force acting on Jada. So clearly there is no force. The force, net force, is 0 newtons, and that is because there is no acceleration. Okay, so there's no acceleration because her velocity is constant. There is the clue. Okay, so that's the answer to A. B, nice easy level 1 question. Jada's mass is 65 kilograms. What is her weight? Remembering that weight is a force, so weight force is 65 times 9.8, which is equal to 637 newtons. So that is Jada's weight force. And then part C, I've got another little slide here so that we can draw on it. So it says, on the diagram, draw the forces as labelled vectors acting on Jada. So the easiest one is the one going straight down, which is weight force. Then we've got the support force of the slide, and here's where it gets to level 2 ideas. When we're talking about a support force, the support force always acts at right angles to the surface, so it's at right angles to the slide. Okay, so that is the support force, and then going in along the surface is the friction force. So we've got F there. Okay, so they are the 3 forces which are acting on Jada, and I'm going to draw that separately next door so that it becomes clear. So we've got weight force going down, we've got support force, so that's weight force, we've got support force at right angles to the surface, and we've got friction along the surface, so that we know that we know that the angle between the support force and the friction force is 90 degrees. Okay, and out of that, we're going to try and form a triangle. So in part D, it says complete and label a vector addition diagram of the forces acting on Jada. So for there to be no net force, we need the support force and the friction force to add up to the weight force. Okay, and we always know that weight force acts down, so I always start with that one because it's the easy one. It always acts down. And then what we've got is support force coming that way and the friction force going that way. So it's just like me picking up my vector here and adding it on the end, and there is your right angle. So we've got F support here and F friction here. And I'm just going to write a note into the corner of the page which says support force always acts at right angles to a surface. Really important to know that. And the other important point is that friction force always acts along a surface. Okay, so it's at right angles to for support, and friction is along a surface. So that's your answer to part D, and you'll see that it's an enclosed triangle. Okay, and it's slightly different to, our arrow doesn't go up. Okay, it's the support force and the friction force which are opposing the weight force, which is why there is no net force there. And part E, the top of the slide is at an angle to 40 degrees to the vertical steps. Calculate the value of each force acting on Jada. So I'm just going to redraw that triangle again. FW, F support, FF, and that is 40 degrees in there. So it's asking us to find the value of each force. So we've got a right angled triangle. It just doesn't quite look the same as what you might have seen. So F support, we've got opposite and hypotenuse. We work this out, it's 637 newtons. Okay, so F support, opposite over hypotenuse, so it will become 40. Oh, sorry, 6. Let's write that again. 637 sine 40 for support force, which is 409 newtons, and the friction force here is 637 cos 40, because we've got adjacent over hypotenuse, and that comes out at 488 newtons. Okay, remembering that the resultant force is 0 because the square of the support force plus the square of the friction force equals the square of the weight force. That's Pythagoras' theorem there. Okay, so a slightly different look of a right angled triangle, but exactly the same idea. Please come and see me if you need some extra explanation with that. Thanks.